I'm tackling a problem where I use EllipticEnvelope, a scikit-learn tool, to find unusual data points, outliers, in a dataset with only two features. Think of it as searching for strange dots on a simple 2D scatter plot. This means my data consists of points that each have two values, like. I can visualize it on a simple XY graph. I'm telling EllipticEnvelope that I expect about 10% of my data to be outliers. It's like saying, I think roughly 1 out of every 10 data points will be unusual. It's an educated guess, not a hard rule. This is the specific machine learning model I'm using from the Sklearn library. It's designed to identify outliers based on the shape, ellipse, of the data. This is the step where I train the model. I give it the data so it learns the usual pattern of the data points. After training, I use this to make predictions. The model looks at each data point and labels it as either an outlier, -1, or a normal data point, 1. Here are the labels. Each number corresponds to a data point. -1 means the model thinks it's an outlier, while 1 means it's a normal point. For example, the first data point is flagged as an outlier, -1, the second and third are normal, 1, and so on. This array simply shows the model's classification of each data point as either an outlier, -1, or not, 1. It is directly output from the function. Based on the model's output, which statements about the results are true? This is the core question. Let's check which statement is true based on model's predictions. I'm working with a dataset containing 11 data points. Each data point has two features, making this a two-dimensional dataset. This is the data that I feed into the model to find outliers. I'm using a scikit-learn model called EllipticEnvelope to detect outliers. The crucial parameter is contamination, which I set to 0.1. This tells the model that I expect roughly 10% of my data points to be outliers. This is the step where I train the EllipticEnvelope model using the dataset. I'm essentially letting the model learn the typical patterns in my data so it can distinguish those patterns from outliers. After training, I use the predict method to get the model's predictions on each data point. The output is a list of labels. -1 indicates an outlier, and 1 indicates an inlier. This is the actual output from the predict method. This list tells me which data point is classified as an outlier, -1, or inlier, 1. By counting the number of -1s in the prediction list, I find that the model identified 3 data points as outliers. The model found 3 outliers out of 11 data points. This translates to a 27% outlier rate, 3/11 100%. This is much higher than the 10% I initially expected. My dataset has a total of 11 data points, each of which represents a single observation or instance. I'm using a simple example of a two-dimensional dataset, meaning each data point has two features, like height and weight. Think of it like plotting points on a graph. I'm using a machine learning model called EllipticEnvelope. It's specifically designed to find outliers in data that might follow an elliptical pattern. Think of it as trying to find the points that don't fit nicely within a stretched-out circle. This step is where I actually use the dataset to teach the EllipticEnvelope model what is and isn't an outlier. It figures out the shape of the normal data. The model's prediction, represented by a list of -1s and 1s. A -1 means an outlier and 1 means a point is not an outlier. Let's count them, shall we? 3 of them are outliers. This is a parameter, a setting, for the model. Means I expect about 10% of my data to be outliers. This is simply a guideline. It does not guarantee the model finds exactly that many. I've counted the number of -1s in the prediction output and yes, exactly 3 data points were flagged as outliers. Since I found 3 outliers out of 11 data points, that's approximately 27%, which is higher than my 10% expectation. Yup, more outliers were found than expected. This is incorrect. The contamination parameter influences how sensitive the model is to identifying outliers, but it doesn't fix the exact number. It's more like a suggestion than a rule. Nope. The model predicted a 27% outlier rate, much higher than the expected 10% set by the contamination parameter. We're using a machine learning model called EllipticEnvelope to find unusual data points, or outliers, in a dataset. Think of it like searching for strange rocks in a pile of otherwise uniform pebbles. I've set up the EllipticEnvelope model with a contamination parameter of 0.1. This means I expect about 10% of the data points to be outliers. It's like saying, I think roughly 1 out of every 10 pebbles will be unusual. The model has given me its predictions. Each number represents a data point. A -1 means the model thinks it's an outlier, while a 1 means it's considered normal. So, I see 3 -1s here, meaning 3 possible outliers. Think of it as the model flagging 3 potentially strange pebbles. I have fit my model to the data, meaning I have trained it to identify patterns. Now, I will be comparing these predictions to the data. I counted 3 -1s in the predictions, so I found 3 outliers. That's my final count of unusual data points. Out of 11 data points, 3 are predicted as outliers. This translates to roughly 27%, which is 3/11, asterisk 100%. This is a much higher percentage than my initial expectation of 10%. It's like I expected 1 out of 10 pebbles to be different, but I found almost 3 out of 10. I'm dealing with a problem where I'm using the elliptic envelope model from Sklearn to find outliers in a dataset. It's like using a special magnifying glass to spot the unusual data points. This tells me that I expect about 10% of my data points to be outliers. It's like guessing that 1 out of every 10 apples in a basket is rotten. This is just an initial guess, not a fixed rule. These are the model's predictions. A -1 means the model thinks that data point is an outlier, while a 1 means it's a normal, or inlier, data point. So I can see 3 outliers here, -1, -1, -1. I counted 3, -1s, meaning 3 outliers. But that's 3 out of 11 data points, which is about 27%. That's quite a bit higher than my initial guess of 10%. This refers to the actual output of the elliptic envelope model's prediction, which tells us if each data point is an outlier or not an outlier. It's like getting the results of a test. This is the specific machine learning model I'm using to detect outliers. It's a great algorithm for finding unusual data points that don't fit the usual pattern. Elliptic envelope is an acronym. My dataset has a total of 11 data points. I'm analyzing each of these 11 points to see which ones are outliers. It's like checking each apple in my basket. The data I'm working with has 2 features or dimensions. Imagine each data point as a location on a map with only 2 coordinates. It could be like plotting height versus weight. I'm using Sklearn's EllipticEnvelope, a model designed to find outliers in data that follow an elliptical pattern. Think of it as drawing an ellipse around the majority of your data points. Anything outside the ellipse is considered an outlier. After fitting the model to your data, I use the method to get labels for each data point. A label of -1 means the model flagged that data point as an outlier, while a 1 indicates it's considered a normal data point, inlier. This is the actual output from. It's like a report card for each data point. Each number represents a data point's classification. -1 is a fail, outlier, and 1 is a pass, inlier. This parameter tells the model, hey, I expect about 10% of my data to be outliers. It's a guideline, not a strict rule. I counted 3 -1s in the output. That's 3 outliers out of 11 data points. Doing the math, 3/11 asterisk 100%. I find that's approximately 27%, not the 10% I initially expected.